Question 16a. A person wins $1 million in a competition and decides to invest this money in an account that earns interest at 6% per annum compounded quarterly. The person decides to withdraw $80,000 from this account at the end of every fourth quarter. Let AN be the amount remaining in the account after the nth withdrawal. Part 1. Show that the amount remaining in the account after the withdrawal at the end of the 8th quarter is A2 equals 1 million multiplied by 1.015 to the power of 8 minus 80,000 multiplied by 1 plus 1.015 to the power of 4. The following are the marking guidelines for question 16a, part 1. For 1 mark, we have obtains the expression for A1 or equivalent merit, and for 2 marks, we have provides correct solution. Firstly, the interest rate per quarter is equal to 6% per annum divided by 4, which equals to 1.5% or 0.015 in decimal. Now let capital R equal 1 plus 0.015, which equals to 1.015, and that represents the increase per quarter. Let P equal 1 million, which represents the principal, and let M equals 80,000, which represents the withdrawal at the end of every fourth quarter. Now A1, which represents the amount in the account after the first withdrawal, is equal to the principal multiplied by capital R to the power of 4, since there are 4 quarters of compounding before the withdrawal takes place, minus 1 withdrawal. Now A2, which is the amount remaining in the account after the second withdrawal, is equal to the amount after the first withdrawal, so whatever the amount is in the account after the first withdrawal, multiplied by another 4 lots of compounding, so that's capital R to the power of 4, minus another withdrawal, M. But A1 is equal to P times capital R to the power of 4 minus M. So substituting PR to the power of 4 minus M for A1, we get A2 is equal to PR to the power of 4 minus M in brackets multiplied by R to the power of 4 minus M. Expanding the brackets, we get A2 is equal to PR to the power of 8 minus MR to the power of 4 minus M. And factorising out negative M, we get A2 is equal to PR to the power of 8 minus M outside of 1 plus R to the power of 4. Now substituting back the values for P, R and M, we get A2 is equal to 1 million multiplied by 1.015 to the power of 8 minus 80,000 multiplied by 1 plus 1.015 to the power of 4 as required. Part 2. For how many years can the full amount of $80,000 be withdrawn? The following are the marking guidelines for question 16a, part 2. For 1 mark, we have obtains an expression for AN or equivalent merit. For 2 marks, we have correctly sums the series and equates AN to 0 or equivalent merit. And for 3 marks, we have provides correct solution. From part 1, we can generalize a formula for AN, which is the amount remaining in the account after the nth withdrawal. So we have AN is equal to PR to the power of 4n minus M outside of 1 plus R to the power of 4 plus R to the power of 4 squared plus R to the power of 4 cubed plus dot 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 plus R to the power of 4 to the power of n minus 1. Note that we have a geometric progression here, and we can represent this sum using the sum of a GP formula. We have n terms and a common ratio of R to the power of 4. So AN is equal to PR to the power of 4n minus M outside of 1 minus R to the power of 4 to the power of n, which is just R to the power of 4n, over 1 minus R to the power of 4. Next, we solve for n the equation AN equals 0, since after multiple withdrawals of $80,000, eventually the account is going to have 0 in it. So 0 is equal to PR to the power of 4n minus m outside of 1 minus r to the power of 4n over 1 minus r to the power of 4. Next, we're going to make r to the power of 4n the subject of the formula. And we're going to do that firstly by multiplying all terms by the denominator 1 minus r to the power of 4. So we have 0 is equal to 1 minus r to the power of 4 in brackets multiplied by PR to the power of 4n minus m outside of 1 minus r to the power of 4n. And then we're going to expand the brackets. So we have 0 is equal to PR to the power of 4n minus PR to the power of 4 multiplied by r to the power of 4n minus m plus mr to the power of 4n. Next, I'm going to switch a few terms around, and just to clean up this equation a little bit, I'm going to make this negative m into a positive m. So imagine moving that negative m over to the other side. So we have m is equal to PR to the power of 4n minus PR to the power of 4 times r to the power of 4n plus mr to the power of 4n, and then switching both of those sides around. So we're going to have PR to the power of 4n minus PR to the power of 4 times r to the power of 4n plus mr to the power of 4n equals m. Since we're going to make r to the power of 4n the subject, I wanted r to the power of 4n to be on the left-hand side of this equation. And notice that these three terms contain an r to the power of 4n component. And we're going to factorize that out. So we'll have r to the power of 4n outside of p minus PR to the power of 4 plus m is equal to m. Dividing both sides by what's in the brackets here, so p minus PR to the power of 4 plus m, we get r to the power of 4n is equal to m divided by p minus PR to the power of 4 plus m. Next, we're going to take logs of both sides. I'm going to use the natural logarithm, so taking ln of both sides. And by doing that, we can use one of the log laws. This 4n will come out to the front since it's an index. So we're going to have 4n multiplied by ln of r is equal to ln of m divided by p minus PR to the power of 4 plus m. And just notice the use of the brackets there. And then dividing both sides by 4 ln r. So I'm going to leave the n on its own there. So n is equal to ln of m divided by p minus PR to the power of 4 plus m, all enclosed in their respective brackets, divided by 4 ln r. Now we have a value for m, we have a value for p, and we have a value for r. So substituting those values back in and just entering in this expression in your calculator, n is equal to 24.463, so on. And we're going to round that down. So therefore, the full amount of $80,000 can be withdrawn for 24 years. The following is the feedback from the Marking Centre for question 16A. Students should find the amount remaining in the account after the withdrawal at the end of the 4th and 8th quarters by explicitly showing the progression from A1 to A2. Present all working out with clear and sequential steps. Use patterns to generate an expression for AN as a summation of terms, and use the correct value for the common ratio when finding the sum of a geometric progression formula. In better responses, students were able to solve logarithmic equations. And areas for students to improve include understanding the steps required to show a result, and improving accuracy and skill in algebraic manipulation of logarithmic equations.